My project has to do with one of the icy moons of Saturn, Enceladus. Enceladus is the sixth largest moon of Saturn, and it sits in the E ring, which is the outermost diffuse ring of Saturn. And the motivation for looking further into the evolution of this ring is because we noticed that there are several moons in the E ring, as you can see, with a lot of the smaller ones being covered in regolith, so a thin amount of some surface material, and they've been spectroscopically and photometrically seen to be ice particles that were probably accreted from the ring, but that has not been looked at dynamically. It has only been looked at from a geoscience perspective. So to begin this project, what we've been doing so far is running N-body simulations using the N-body integrator Rebound and Rebound X, which is a code written in C. And it's important because it simulates resonances in the system. Because a lot of the moons in the Saturnian system are actually linked to each other orbitally with integer ratios. So every time this small moon Mimas goes around Saturn twice, the outer moon Enceladus goes around once. And these integer ratio periods help keep moons stably locked in systems. And to go about simulating an eruption off of Enceladus, what we did was that we had a singular eruption come off of the south pole of Enceladus from two latitude angles, 79 degrees south. We implemented 4 different grain sizes, which were seen by Cassini BIMS in 2015. Quarter micron, 1 micron, 2 micron, and 3 micron sizes. We included effects such as plasma drag force, which is it's a force that is created by Saturn's co-rotating magnetosphere that causes the plasma to allow particles to actually drift upwards. This was actually really important, and when I discuss my results, you will see that it plays a pretty big role in kind of why this system is more confusing than we thought. And so running these simulations for over 30,000 particles and for a span of 60 days, we found that the E-ring is probably not able to paint the moons like this over a single eruption because not enough material is being cleared up by a moon in a certain amount of time. Only a small fraction of the material is cleared up by the moons, and the quarter micron grains actually end up drifting so fast that by the end of 60 days...
Tell me, where are we in this picture? Where is the Earth?
Oh, it's like over there somewhere. This is Saturn, and this is
the moons of Saturn.
And the end of Saturn's system is like here. So from here to like here is Saturn.
And the Earth is way...
Like somewhere out there, yeah, near field.
It has 12 moon, I think, Saturn.
It actually has like 70 something moons.
70?
No.
Yeah. 78 moons.
Mm-hmm.
Yeah.
And every moon has a different speed.
Yes, and different orbit. And then there are some moons where the moons are co-orbital, which means that there's one big moon, and then like if you're doing like ring around the rosies, there's one moon ahead and one moon behind, and they rotate like this around Saturn. And so this is one of the small moons that's actually rotating in front of this moon, Tethys.
Okay, go ahead. Sorry.
No, it's okay. Yeah, so we just found that actually the particles are not being cleared by these moons in enough time. So we think that for moons to be thickly covered like this one, they probably need to have existed in a steady state ring for a very long time. That's it. You can ask me questions now.
Well, the question is, why out of everything you're so concerned about those moons? what is so important about that?
Okay, so Enceladus, the moon that I'm studying itself, it has, it's made out of ice, and it's got an ice shell, and it's got water in it, and it's got an ocean. How do we know? So we sent a spacecraft there, and it was in Saturn for 20 years in the system.
Oh,
It's
really?
called Cassini, yeah. It only was terminated like in 2017 when they flew it into Saturn directly. And it took lots of images like this and this and this. And it did a really good job of looking at the moons, but it also flew through Enceladus. So Enceladus, like I said, it's icy, but it has cracks on the very bottom. They're called tiger stripes. It's fissures in the shell of the moon, and water ice is being erupted from the bottom, and it's spraying the area. Yeah, and so Cassini, the spacecraft, actually flew through the water ice, and it found organics, and that the water that's coming out is like salty seawater from Earth. It's very similar. And so it's important because this might actually have some sort of implications for life.
What are the temperature ranges on this?
I think it's somewhere like negative 270 degrees Celsius.
So it's like Canada.
Yes. So that's why they think there could be extremophiles in the moon, which means bacteria that can exist in harsh temperatures that we've found in Earth.
So they really went there and this
The spacecraft.
Put them in.
spacecraft and
Yeah.
they found out the ice and water and all that. And still some probes are there.
No, both of them died.
Passed away. What other signs do you look for to indicate life?
You look for biosignatures, so things like oxygen, nitrogen, and carbon, which have all been found in the water ice that's been erupted.